as well. All right, so let's go ahead and get started here. I'm going to, let's see here, make sure, what I'm probably going to do to minimize distractions here is I'm going to just take myself off video after I do the introductions. Let's go ahead and just go through a quick introduction. As far as housekeeping, the first thing is of course, I want to welcome everybody aboard. I really appreciate you joining on this Thursday, late Thursday morning on the East Coast. I know some of you may be joining from other time zones and countries, etc. So appreciate your earliness or lateness in your day. With that said, we have a busy 3 hours ahead of us. During the 3-hour session, we will be taking at least one break, possibly 2 5-minute breaks, depending on how we're doing on schedule. Feel free to put in chat any questions you may have. I will certainly be addressing them in intervals usually, unless if I see it right away, I'll go ahead and address that as well. During this course, we're gonna be covering some areas, and again, I'll get my video here. Hold on a sec. Oops, there it is. Okay. I'm going to go ahead and shut up my video just because I got to move stuff around. I've got this big monitor wall, and that's how I like to work, so it's easy enough for me. Okay, so quick introduction before we get into the content. Also, too, feel free to put in chat where everybody's from. I always love to find out where people are located. Nothing confidential or anything, just are you based out of Boston or Toronto or India, Australia, wherever that may be? That would be great to know. So my name is Joseph Holbrook, and I am, let me get my little thing here. Okay, there it goes. Quick reminder here, make sure you raise your hand if you have any questions or anything, or put in the chat. We will, of course, be passing out a recording of this, and you do have the PDF download as well. My name is Joseph Holbrook, based out of Jacksonville, Florida. It is wet and rainy today. And not exactly, your typical thought of Florida day. Cold, about 50 degrees, but for those not familiar with, the geography of Florida, I'm up in the northern part of Florida, right near the Georgia border, and not like down south like in Miami or Tampa or something. I am a widely published course author and instructor, blogger, author as well. Looking forward to spending some time with you. I am certified by pretty much any vendor that you can think of. I've done a ton of different roles such as pre-sales, post-sales, implementations, design, training, you name it. I hold certifications from Google Cloud, Amazon Web Services, as well as Cloud Credential, CompTIA. I'm also a CompTIA subject matter expert. I help design the certification exams for the CompTIA Cloud Plus, for example, the first revision of it. Also, I've worked for Hewlett-Packard Enterprises for 3PAR Data, Hitachi Data Systems, Federal, EMC as a contractor in numerous roles, Dimension Data, many other companies. So with that said, that's enough about me. Let's go ahead and get into the content, and I'll check the chat as well and see what people are saying. Okay. Okay, in case folks on Mars are watching. Okay, Mississauga, Ontario. Okay, Ontario, a lot of Canada. Wow, okay. Great, Vancouver, Canada. Okay, so you got up a little early. Gatineau, and oh, wow, we have folks from the islands and up where it's really cold. St. John's and Newfoundland. Dallas, Texas. Okay, great. Alberta. Wow, okay. All right. Wow. Okay, quite the representation of Canada as well. Atlanta, Brampton. Good stuff. Good stuff. All right. So let's go ahead and get started. I'm just going to go ahead and get my video out of the way here and maximize the screen a bit as well. All right. Thanks everyone for joining. Toronto. All right. Excellent. All right. What are we going to talk about here? We are going to talk about quite a bit in 3 hours. I have like over 120 something slides. To be honest, we're going to do a good amount of demonstrations and walking you through some of the platforms and just doing a touch and go on certain subjects. I'm going to try to do as much as I can. We do have a lot of content as well, so I'll try to keep this as interesting as we can and in the short amount of time that we have. We're going to be getting into Cloud Security 101. One of the things that I think is important is to define what cloud security is, what exactly are companies doing, and what are the vendors sort of talking about. We'll get into some of the cloud computing risks and governance issues that come up as well. I'm going to talk about DevOps as well. One of the things that in the last year and a half or so, I have noticed, I wouldn't say a ton of companies, but quite a bit of companies are going to a DevOps approach, not just in-house, but for the cloud. So I'm going to talk about some areas around DevOps and how that plays into cloud security. And I'll also talk about some of the tools that are available on the, on the vendor, or actually on the cloud provider platforms as well, such as AWS Code Pipeline or Kubernetes Engine over at Google, or Cloud Build on Google Cloud, for example. We'll go ahead and touch on the 3 major platforms. I will then get into security controls around cloud computing and talk about vulnerabilities that are pretty common. And then we'll get into each of the platforms more directly. So we'll talk about AWS security best practices, features, Azure and Google Cloud as well. I'm also going to touch on a new area of threats that has been sort of popping up quite a bit, to be honest, and that's around cryptocurrency mining. And I'll briefly touch on some areas that you as a cloud architect or cloud engineer, whatever your roles may be in the cloud or in your IT and environment for that matter as well, I'll talk about cryptocurrency mining, such as Monero, which is hideously easy to set up and start. And I'll also talk about other facets as well, like Ethereum. And then one of the things with the cloud providers is if you have a rogue employee, this rogue employee using your cloud platform can spin up all these EC2 instances or Compute Engine instances or Azure VM instances and be mining cryptocurrencies without you even really knowing what's going on for a few months until you get that bill. And this has happened more than a few times. So even though you would think people would know better, sometimes they just don't. But with that said, that's one of the new areas I find really interesting. I'll talk about the current threat landscape as well. We'll talk about the top 10 techniques for reducing your risk. And lastly, we'll wrap it up talking about some cloud security certifications. And also, I'll talk about some additional training that's available as well if anybody is looking to get more advanced certifications or classes. All right. So the course itself is 3 hours. We're going to really focus on cloud security and cloud security best practices. I'm going to walk through some demos as well and also provide you with additional resources. With that said, before we get started into the content, I did have 2 questions I'd like to just have folks answer. I'm going to go ahead and launch the poll. And feel free, let us know what you're doing for cloud providers right now. That way I can sort of cater my discussion based on, okay, wow, this is pretty, okay, pretty good. I'm very surprised. Okay. Okay, AWS, GCP, and Azure are pretty well balanced from what I usually would see. Okay, interesting. So we'll give folks a little bit more time. Looks like about a third of the folks entered their comments here. Great. Okay, so it looks like the majority is actually Azure. Wow. Okay, interesting. All right, looks like about half voted. We'll give folks another minute to finish up, but really interesting feedback that I'm seeing so far. Great. And for the folks that entered other, if you'd like to put it in chat what you're using for cloud services, that would be great. I didn't cover like Oracle or Cisco or anything, but would be interested, and I'm happy to point out some additional best practices that I'm aware of for other platforms if I'm aware of which ones you're on. All right, so give it another 5 seconds and we'll move on. All right, so let's see. We have 54% with AWS, 20% with Google Cloud, and 66% with Azure, and 20% with other. All right, excellent. And let's share the results. And you should be able to see the results as well. Let's look at the chat while I'm here. PCF, oh, okay, Cloud Foundry, okay, that's more of a private approach. Okay, good, good. And Cisco, okay, good. Yeah, Pivotal is sort of a niche area, awesome platform as well. Great to see that some folks are using it. Okay, so you should be able to see the results there. All right, we'll go ahead and go to the next question quickly here. And that's not the one I want. And why in the world is that not coming up? Hold on one sec. That's not what I wanted. Okay. I'm technically challenged with this poll here. Why is that not coming up? Okay, I know why. All right. Poll number 2, give me 1 second just to pull it up. And just curious about certifications, what people have. And okay, I don't know why. All right, well, tell you what, I'm not going to play games with this poll here any longer. I don't want to hold up your day. What I'll do is I'm just going to put it in chat. Feel free to let us know. And right there, I just put in a little thing. If you just let us know what certifications you have, that would be great. We'll go ahead and get started again. Okay. Okay. All right. So I put something in chat for everyone. Let us know any certifications that you maintained around cloud computing, like AWS, Azure, Google, CompTIA, Cloud Credential, CSA, or anything of that nature. That would be great. Okay. We'll go ahead and move on and talk about cloud security. So cloud security, one of the things to really just make sure we all understand is that it's really a shared responsibility. It's a model that isn't 100% the consumer. It's not 100% the provider. And it's really a team effort. And we'll get into what the subscriber is responsible for. We'll get into what the provider is responsible for as well. And we'll talk about the different service models, deployment models quickly as well, just to give everybody an idea of where we're going to go. Now, when it comes to cloud computing security, it is generally viewed as a complex area. What I mean is generally people somehow, and when I say people, I just mean the technical audience has a tendency to typically make it more difficult than it is. And in reality, the provider, in a lot of cases, makes things somewhat easier for you as a technical engineer, as a technical architect. And we'll talk about AWS, Google, and Azure on what they do to make your life easier. However, a lot of the challenges that come into play is usually just because of a lack of understanding of how things work, not taking the time to find out, or not being trained properly, or not reading the docs, following best practices. So I just always like to tell my customers and my students that sometimes things are not as difficult as they're typically made out to be. I will say that working for many vendors in the past, when you sell a solution, you need to make it easy enough so that the customer stays with you, but hard enough so that the customer stays with you. And what do I mean by that? Well, you don't want to make things too easy so that you as a provider, you don't have recurring revenue from support, from professional services, from additional licensing. Those are typically the three main ways. And especially like with AWS, these folks at AWS have mastered the art of basically recurring revenue and increasing revenue per customer. And we'll go into some of their services. I'll talk about briefly, if time permits, pricing and how this all works, but I really want to focus on the technical aspects. But the main message I'm just trying to get at here is, let's not make this more difficult than it really is. All right, now when it comes to protecting your critical information, you want to protect it from a wide variety of threats. And there's been several studies that have been done when it comes to, and our friends that are CISSPs or, you know, CompTIA certified professionals, you would know that the greatest risk to your environment is not typically someone from the outside, it's usually an insider. And this is true with the cloud, and I'll go through later on in the course, you know, lots of examples of things that went wrong where the customer, you know, the customer security management, CISSP, CISO, whatever, whoever's running the show, didn't think of some very basic things, like what happens when someone leaves the company. Or my favorite is, you know, what do you do when you have a rogue employee that didn't like his performance review and decided to shut down with the Trojan horse, you know, so that it wasn't too evident that it was him that did it, and shut down your Office 365 and Azure services? You know, what do you do there, right? So a lot of things could be prevented. All right. Now, let's talk about, for example, with AWS. AWS uses the shared responsibility model. And this is exactly what it sounds like. It's a shared responsibility. You, the subscriber, the customer, and the provider. There's a distinct area, you know, depending on the service model that you have to maintain. And we'll talk about that coming up here shortly. AWS owns the infrastructure, the network, and the hypervisor, for example. But the enterprise owns the workload, the apps, the networking that's set up to get to your VMs and out to the cloud or from the cloud, and any other data that they generate. So with AWS, we have the shared model. And you can see that the orange is AWS and the customer is basically blue. Now, this is very simple from a high level. On the other hand, this could get pretty challenging because there's a lot of moving parts here. What about if you're a customer that is going to deploy, let's say in Google Cloud, that you're going to deploy a compute engine, Kubernetes engine, cloud functions, and to top it all off, let's say, you know, some data services like, I don't know, BigQuery, Bigtable, cloud storage, whatever. So each of those services that you're going to deploy will have specific responsibilities that you need to pay attention to from a subscriber standpoint. And each of those are moving parts and challenges to understand. So how you deploy your, let's say in Amazon, you know, how you deploy your AMI, you know, is up to you. You need to pick the right AMI that makes sense. You need to create your customization that makes sense. If you're gonna deploy custom images, you need to, you know, consider using tools like CloudFormation, whatever, you know, whatever specific requirements you have, you're going to have to, of course, model your deployment approach to fit that requirement or those requirements. So let's talk about this some more here. But let's, before we move on to the next section, one of the things to be aware of is the cloud providers do provide you tools to help identify, for example, threats, vulnerabilities, etc. Google Cloud, you have Security Scanner, AWS Inspector, etc. So we'll talk about each of the services in detail, talk about Azure as well. All right, let's talk, before we get into specific providers and a little deeper details around security best practices, let's just make sure that we understand the foundation of cloud security and cloud computing for that matter, first of all. Now, the National Institute of Science and Technology is really the de facto standard for standards around cloud computing. They were the ones that really came out with the best practices and helped define basically what cloud computing is. Now, this was a result of several challenges that the government, for example, about 10 years or so ago had with cloud computing. And NIST, for those that are not familiar with the National Institute of Science and Technology, NIST is essentially a quasi-governmental organization in the sense that they serve both government customers, but also they serve commercial customers indirectly. And this organization is actually under the Department of Commerce. And they're located right outside the Beltway in Washington, D.C. I think it's Gaithersburg off at 270. And they still have, you know, what I would call a lot of conferences and, you know, best practice meetings. What's the term I'm looking for? Basically, you know, developmental focused groups to help identify areas of improvement. Working groups is sort of what I was trying to get at. And again, you know, that's NIST. So they really were the ones that came up with sort of the approach that's still used today. Now, there's competing basically models out there, for example, from IEEE, but also from the Cloud Security Alliance as well, CSA. But NIST is really, you know, the granddaddy of defining cloud. Now, we'll get into, for example, the service models, deployment models briefly here. Again, we want to focus more on security than Cloud 101, but we want to just give folks without that broad knowledge, you know, a good head start here. So the first thing to point out is that cloud has specific characteristics. It is on demand, meaning that you as a customer can spin it up. It is self-service in the sense that you're doing it yourself, correct? And then it is a broad network access. Now, broad network access does not mean that your AWS or Azure instances should be, you know, basically, you know, open to everyone, right? You know, you shouldn't have those Amazon S3 buckets open to the public, okay? Again, not a good practice to do. So what this means is that you can access your resources from anywhere on any reasonable device. Essentially, you can access on an iPad, an Android, your desktop, even your phone if needed as well. And you could do it from Brazil, China, on American Airlines, over the Atlantic, whatever you so choose. Again, you know, having enough bandwidth is another story, but I'll leave that up to you to figure out. That's essentially broad network access. Now, resource pooling is just basically saying we're all going to get together and share resources. Now, resource pooling is where the cost effectiveness really comes in. If you didn't have resource pooling, then you wouldn't really have cloud computing because of the economics wouldn't really make sense. You would have, in effect, more managed services than anything. Now, rapid elasticity is just stating that, we could scale up and scale down as required. And then we have measured service. Well, this is essentially you use what you use and you pay for what you use and nothing more, nothing less. In other words, you're going to get a bill. This is basically your charge back and your bill back capabilities in cloud computing. Okay. Now, when it comes to NIST, they've defined probably one of the most famous pictures or whatever you want to call it, diagrams or, feel free to, whatever you want. Probably one of the most famous, pictures you're ever going to see in cloud computing is this specific model that was developed by NIST. And this model is very modular. And what I mean by modular is that you break down each of these sections. And there's actually additional layers under it. But there's 5 roles. We have the consumer, which is you using the service, the provider providing the service. We have the cloud carrier, which is the telecom provider in most cases. And then we have the cloud auditor, which is going to audit the services and validate either security, privacy, or performance. And we will focus on the security aspect for this course. We won't have time to get into performance or privacy per se. However, I am going to touch on GDPR because GDPR is like getting a root canal for a lot of companies. And actually, our friends up in Canada, you also have another regulation to deal with called the right to be forgotten or something of that nature. I'll look up the exact acronym that's used. But basically, if a customer calls up, we want to be able to disappear. And as part of that, this is some of your privacy issues you may run into. But I want to really focus on the security aspect. But I will touch on privacy briefly. And performance, we'll have to have another webinar in itself for that another day. All right. No, I didn't cover broker. Now, broker is an interesting approach because a broker does what? They're like a middle person, right? A middleman, a middle woman, however you want to, look at it, or a middle organization. I like to call it the middleware for the cloud. Basically, a broker could be any organization that is going to generally help the consumer and the provider meet up. I call it, I like to joke, it's like the Match.com for cloud computing, That's really what it is. It brings people together. So some examples of cloud brokers could be, for example, Dimension Data, NTT. Also, too, a lot of organizations like, for example, Deloitte have services. They don't act as an official broker, but their goal is to help, bring the right use case to the right provider, and they get paid for doing that, and they're partners of the cloud providers for a reason. Anyways, and again, it's not, in the government sector, there's a ton of them as well, like CSC, Booz Allen Hamilton, so on and so on. Anyways, with that said, that's just a quick little sort of touch and go on the model. The links for the publications are here. I'm going to just, for time purposes, not show you every link that I put in here. this is for you to investigate. The architecture is the first link. The second link is going to be the security reference model. Now, the reference model is going to be something I would recommend that you take a good look at. It is a PDF, and let me go ahead and share this. I just wanted to show you a couple things in the security areas that we're going to focus on here. Let me just go ahead and share this. And where is my PDF? There it is. Okay, so you should be able to see my PDF. And this is, first of all, the standards roadmap. And if you go through the document, you can see that there's a lot there. But when you start getting down into past the history, past working groups and publications, they have, you know, a lot of best practices in here, the characteristics, deployment models, service models. So this is really the, you know, the de facto document for cloud computing. And if you need to get more information on what cloud computing is, again, we're really not here to cover all the basics, just to cover security focus. I would highly recommend you take some time to look at these PDFs. And this actually explains like what a broker does and, you know, how they make money and how they bring the customers together. So that is essentially one of the documents you might want to look at. Okay. Let's go ahead and share this screen again. When it comes to service models, we have basically software as a service, platform as a service, and infrastructure as a service. It's really important to appreciate the different service models. We're going to talk more about them and give you some examples. Deployment models, again, we want to understand the differences between them. And I'll talk about a private cloud versus a public cloud, the benefits and stuff like that briefly as well. And then we want to understand the threats and the risks and the vulnerabilities to cloud computing because of these models. Because, well, actually, let me just restate that. Especially, not because, but especially because the way we deploy our cloud services can either mitigate some of the threats or basically integrate threats or reduce the threats or basically produce the threats, however you want to look at it. Basically what I'm trying to get at is you have to pay attention to how you deploy your services because each of these service models and deployment models will have pros and cons to them. And I'm going to focus mainly on infrastructure as a service, but I'm going to touch on platform and software as well. Okay. So cloud security is essentially a shared model. We get that, right? Cloud security is hard and in the sense that there's a lot of moving parts, but at a hierarchy level, it's pretty easy from a responsibility level. You know what you have to do. The provider knows what they have to do. And to be honest, the hardest part of cloud security is just trying to understand how the vendors do things and how you have to address, for example, IAM in AWS versus Azure. Now, the reality is that two of the providers, you know, handle things very, very similarly. One of the other providers handle things a little differently. And each of them have different best practices. We're going to get into that area. I'm going to hold off and getting too deep into some of that until we get to AWS and Google and Azure. Okay. When it comes to SaaS, the provider is responsible for the infrastructure, the intermediary layer, and part of the application layer. Now, the intermediary layer is going to be basically A question looks like we have. Let me go ahead and pull that up. Oops. Hold on one sec. It's really weird. Okay. I don't know why that's really weird. Yeah, this is, hold on, let me go ahead and stop sharing. That's just odd. All right. Okay. Hold on, I think I know what I did. Okay, let me change to the advanced mode here. All right. Okay, and we'll get to your question. I didn't forget. Oh, there it is. Okay. Now, and go ahead, Mohammed. I'm going to go ahead and I just pressed it. Sorry for the hold up. Question, Mohammed? Okay, for some reason the audio, or I don't know if I don't see any movement on the audio. Okay. Says you're on mute. It's not because of what I'm doing. That's weird. Mohammed, are you on mute? Okay. Should be on mute. Let me just, that's weird. All right, well, I don't know what is, because I am clearly hitting unmute, and it still isn't letting me. All right, we'll have to have one of the moderators look at that, because I don't know why it is, because you're totally enabled to talk, but it's showing it's on mute, but I don't know why it's not unmuting. Okay. All right, Mohammed, feel free to put it in chat until we can figure out why this audio isn't going through. Sorry for the holdup. I will see if someone at WebAge can figure that one out. All right, now, when it comes to the way something is deployed, once again, if you deploy it in a SaaS approach, the provider is really responsible for pretty much everything except your data. You need to import your data. You need to save your data. You may need to update your user list, some of your IAM policies, but in general, your whole goal in life is accounts and permissions. Now, in platform as a service, this is a little bit different for the consumer and the provider. Generally, the provider is going to do somewhat less, and the consumer, the subscriber, will be actually doing a little bit more work. Now, let me get some water, one sec. Okay, Mohammed raised his hand again. Let me see if this is going to go through. Like I said, I don't see anything. What is going on here? Let me try that one more time. Okay, participants, unmute. Okay. Okay, Mohammed, can you speak now? All right, that's really weird. Okay, because I actually made you a panelist. So you have literally full speaking rights. Okay. I literally unmuted all. Okay, can you speak up now, Mohammed? All right, when we go on break, I'm going to do a test on my end because this should be working. I don't know what is going on, and it looks like the WebAge panelist disappeared. So sorry for the hold off. We'll have to take questions later verbally. However, if you want to place it in Q&A or chat, I'll be more than happy to answer as well. Hopefully that'll work. Because everybody should be able to. Okay, so I'll place you back as attendee. All right. All right, sorry for the delay. Let's speed this up just a little bit. I do want to give plenty of time for questions, and we'll take a break and I'll work on the audio on my end. I don't know. I'm going to test. I'll have my wife dial in and we'll try it, but the WebAge folks are not available. I don't see anyone else online. Okay. Now, when it comes to platform as a service, this is actually one of my favorite approaches to the cloud because it's like the right mix of, basically what I like to call privileges, but it's also the right mix of the right use case. And what I mean by that is this: if you're a developer, then it allows you to not have to worry about the underlying infrastructure, and you don't have to worry about deploying VMs. You don't have to worry about a lot of this. You can in a lot of the platform as a service approaches, but it allows you as a developer just to get your job done with just enough permissions to deploy your runtime environments, to be able to deploy your services. And also a lot of the platform as a service capabilities out there, whether it's from AWS or Azure, so on and so on, they have a lot of good tools that you can use to help alleviate some security issues in your development processes. And I'll talk about some of those tools when we get to the specific areas like AWS, Azure, and Google. Now, infrastructure as a service is going to be where you deploy your run-of-the-mill VMs, where you're going to just deploy the VMs, and you're responsible for loading the OSs and the permissions, etc. that you need, setting up your firewalls, your security, etc. Now, when it comes to other pictures that are out there that you see quite a bit of, this is one of the more common ones that you'll see. When it comes to cloud computing, we have what's called pizza as a service. Now, generally, this is compared to, if you look at the way the tables are aligned, you have traditional on-prem. This is made at home. This is basically what you're already doing in your environments at your corporations. In other words, you're handling everything yourself. You're handling the patching, you're handling the deploying the VMs, deploying the networking structure, etc. And then infrastructure as a service is where it's sort of like going to Papa Murphy's and picking up a pizza, or going to the grocery store and picking up a pizza that's already made and you just bake it. And then we have platform as a service. This is similar to you calling up Pizza Hut or Domino's or whatever pizza services you may have in your areas. And then software as a service is where you just go out to dinner, everything's put together with you, you just pretty much pay the bill. When it comes to cloud models, this is an example of Windows Azure, basically, and how things would be managed, for example, in a typical cloud approach with Azure. And this is pretty similar, not just to Azure, but any of the cloud providers in general. So on-prem, that's where you deploy all your services. You handle everything. Microsoft does nothing but sends you a bill pretty much for your licenses and support. Infrastructure as a service. This is going to be where you're going to deploy your applications on top of the OS that you install. But the provider, Microsoft, will handle the virtualization, the servers, the storage, and the networking at the virtualization layer, essentially. Now, platform as a service, you could see a lot less to do there. And Microsoft handles everything from below runtime on down. Now, you as a developer, you're going to deploy your applications. So you're going to deploy your Python, your PHP, your .NET, whatever you're developing in, and then you load your data. That's pretty much your whole goal to get started. Now, software as a service is a little different. This is where you're using something like Salesforce or other services, or in the case of Microsoft, it would be like Dynamics or Office 365. And again, all you're doing is essentially adding data, creating data from the service. And one more before we get back to the content. This is another example of how you might compare Microsoft and their services, like infrastructure as a service is Windows Azure, platform as a service is Windows Azure as well. But software as a service, that's where you're going to use Office 365 or Windows Intune, for example. And again, just one quick little comparison for you. And then, we could talk about Google and AWS as well. If we go to AWS, right, we have our EC2 for infrastructure as a service, platform as a service is Elastic Beanstalk, and then software as a service might be like Lambda or something of that nature. And then if we get to Google, we have Compute Engine to App Engine for platform as a service, and then software as a service would be like Cloud Functions or G Suite for Gmail. Those would be comparable services, excuse me. Now, governance. Let's talk about what governance is, because governance is really, from what I've seen too, not just working as a trainer or a consultant, but actually when I did a lot of projects. One of the things I would run into was either there was no governance or the governance was pretty poor. And again, I did a lot of financial and federal sector consulting for years and years, and generally governance of cloud as well as internal IT is pretty poor. Now, some organizations are different. Like if you're an organization that is large and you follow ISO standards, generally your governance is going to be pretty good because that's part of the whole package in a lot of cases. Excuse me. Now, when it comes to governance, we like to just focus on the fact that governance is not management and management is not governance. However, they should complement each other. Basically, you want to create a policy with governance and then enforce it by management. And it looks like I spelled management wrong. That is my typo. Okay. Now, when it comes to risks, some of the risks are going to be related to, now specifically to cloud. You could run into man-in-the-middle attacks. API vulnerabilities, denial of service, spoofing, IP scans, etc. Now, when it comes to what time we have here, hold on one sec. Let me clear my throat. It looks like I'm coming down with something here. 1 second. Okay, sorry about that. Now, for example, for those that aren't familiar with these type of attacks, a man in the middle is typically where, and a perfect example of a man in the middle attack is like the National Security Agency, for example. For those that don't know, everything that we do is literally collected and basically disseminated to government data centers. And it doesn't matter if you're a US citizen or not, it's all being collected. So it's well documented. This has been top secret. It's literally all over the internet. Edward Snowden was the one that sort of clarified these little things. So that's sort of like a man-in-the-middle attack. We have a rogue agency basically collecting everything while you're going from point A to point B. There's really another point that you're going through. I like to compare it from a networking perspective where you have an edge location and then you have your sort of client. And between the client, you're going to go through typically what's called like a director switch to get to the edge. And so there's different, hops you go through. A man in the middle typically is going to be inserted somewhere between the client and the provider, wherever that may be. Okay, API vulnerabilities. Now, anyone that's a developer knows that APIs are not exactly secure. The cloud providers try to make them secure, but it's more than possible they could be hacked. It is more than possible that new vulnerabilities come up. But typically an API vulnerability, now for those folks that aren't familiar with APIs, this is basically an application programming interface. These are used to essentially connect to the cloud service. For example, pretty much all the cloud services are going to have an API to connect to. So for example, like S3 or EC2 or Google Compute Engine, etc. Now, these APIs are basically code that you're using to connect from the client to the cloud provider. So anything that's code is going to be what? Vulnerable to having code inserted or deleted or modified. Generally, those are the major vulnerabilities that can happen. Now, in AWS, there's been some well-known vulnerabilities, for example, where on the break, if I have time, I'll pull up a couple links for you, where the developers might be developing something locally, and they'll write like the log files to Amazon S3. Well, Amazon S3 has a global namespace. And I'm not sure how this came to be, but the API for S3 essentially is basically like almost root privileges for everyone, unless if you specify otherwise. And we'll talk a little bit more about how that works, but it's sort of odd. So S3 APIs are, it's a global namespace. That in itself, because it's a global namespace, makes, for example, S3 a little bit easier to sort of make guesses. For example, that someone probably has in the global namespace, my S3 share, or that if a certain company is using S3, that they're probably using specific acronyms to save it. And you could go to S3 and type in, and you'll know that if that name's available, you get it. If it isn't, it's not there. And you also know that the namespace, a certain number of characters, has to be lowercase, can't be certain characters in it, stuff like that. And same thing with Google and Azure in some cases as well. Okay, so denial of service is usually in the cloud. We have a lot of challenges with DDoS attacks. Now, a DDoS attack is what? That's where you have typically bots that are spun up by some script kiddie, you know, us basement dwellers or whatever we're called nowadays, you know, sitting in our basements running code, right? Trying to create problems for the world, right? That's our denial of service folks, okay? But anyways, no pun intended there, just trying to make a little sense of humor out of this. But if you think about a denial service as simply this, it's basically a bunch of nodes that have been hijacked that are sending out what packets to your cloud service or to your website, especially if you're hosting, and a lot of customers host this on the cloud providers. They'll have their merchant sites, they'll have their document repositories, whatever. And as long as it has a URL, you know, and an IP, and you can get to it, it can be DDoSed. You know, you can have a flood of packets to that website or that URL. Now, the way you mitigate DDoS could be numerous number of ways. I'll talk about some of those coming up a little later, but in general, you need to set up auto scaling. You want to set up IP filtering, packet filtering, etc. in a lot of cases. Use geography to your advantage as well, because generally these bots come from a specific geography in a lot of cases. Not always, but you know, again, just you need to look at where the attacks are coming from and where the packets are sort of going from and to, and figure out how you can mitigate that. But usually the first rule of thumb is to scale up by auto scaling so that your site doesn't go down immediately. Another thing too could be spoofing. What is spoofing? Well, spoofing is basically where you're masking yourself in a manner that you know, is like ghosting in another term that's used. But spoofing is you're sort of pretending to be something that you're not. Now, you can mitigate that through several ways. That could be through MAC filtering. It could be through IP filtering. It could also be through geography as well, you know, domain names, etc. A lot of different ways to approach that. IP scans. Now, this is where someone's going to go and, you know, scan for IPs and ports and, you know, tries to mitigate, or not tries to mitigate, tries to take advantage of, you know, ports or protocols or services, whatever you want to, you know, call the vulnerability, that are open that may not have been patched or whatever. A good example of something that should have never happened was with like the Equifax hack, where people, you know, the hackers were able to figure out that, you know, they're running, you know, these applications with Apache, and they did not patch a known vulnerability. Well, you know, scanning can figure those things out pretty quickly if you're not paying attention. Okay, let's do this. Let's take, how are we doing on time? 12:06. Okay, let's take a 5-minute break. I'll come back. We'll get into some of the content, and then I want to get into some of the demos as well. All right, so I'm going to put it on mute. I will see you back in 5 minutes. And let me pause the recording. Now, I have 12:06. Let's come back at 12:11. All right, so, yep, that has started again. Let us share the, let's see, where the heck was I? That's interesting. It blows that all away. I got to start over. Okay. All right. Now, let me get back to the slide I was at. All right. Okay. Now, that is just odd. Hold on a second. My bad. Okay. That's where we should be. All right. Now, let me just make sure you can see that okay. And does everybody see that okay? I just want to make sure that propagated okay. Okay. Could someone just raise their hand or something? Just let me know it's okay that you see the screen. All right. Thank you so much, Sadir, Jose, Linda. All right. Excellent. Thank you. All right. Great. I just want to make sure, just because sometimes when you upload these new plugins, it's amazing how some things work and some things just don't. Okay. All right. Now, let's talk about some important aspects. So I have about 100 slides to go in 2 hours, so I'm going to pick up the pace a little bit. We've got about 20 minutes of demos I like to do and walking you through certain features and stuff as well. So with that said, let's talk about authentication and authorization. Generally, when it comes to authentication and authorization, these are areas that get confused pretty routinely. Authentication is really what's considered an act of where you're basically saying that this is the identity that this person is saying that they are. Now, authorization is different in the sense that you're essentially saying that this is correct, that you're being authorized based on your authentication, essentially, that you have access to these cloud resources. So just think of authentication and authorization as two different factors. Now, generally, when it comes to cloud computing, we're going to talk about multi-factor authentication as well. We'll talk about some of the services that are there that you'll run into. But in general, the main thing to make sure that you get is, let's see, I have a question here. Yes, yeah, that is true as well. Good point, Sam. Sam is saying NIST has a great model for authentication as well, with role-based access security and ABAC as well. Yes, yeah, point taken. Thank you for sharing that as well. Now, you could also, when it comes to credentials in the cloud, one of the things to pay attention to is most cloud providers, at a minimum, will have identity and access management control already ready to go. Now, multi-factor authentication is a little different. It's another layer that's added on top of the basic IAM capabilities. Now, one of the other things to pay attention to, for example, is you could go to AWS right now and create an account. And it's up to you, though, if you want to enable multi-factor authentication. However, if your administrator, on the other hand, chooses to enforce multi-factor authentication, that, of course, is something that's true. And same thing with Google Cloud and Azure. The way these are implemented are similar, but the way you actually implement them could be very different. And we'll talk about that as well. And then access keys, again, you need to have an access key. Generally, two, you're going to be typically using public key encryption. You're going to want to save your PEM file. For those that aren't familiar with PEM file, you're going to download your, basically your PEM file and save that locally so that you can access your services remotely. You need to have that secret key to be able to access your cloud services. And this is very true, of course, for your command line and your API services. Now, one of the things that typically comes up as well is that a lot of the development around applications now are focused on what's called REST APIs. Now, REST APIs are going to use operations that are going to be HTTP focused. That means they're going to use that protocol. These are very simple, very robust APIs in a lot of cases, like with Google Cloud. Actually, same thing with Azure as well, and AWS. You could basically tie in these services to like a cloud endpoint or an API gateway to manage these effectively. Now, generally, too, the certificates are going to be in X509 format. That's going to be your private and public key formats. Now, federation, one of the areas in your cloud that you're going to typically want to focus on is going to be around federated identity. Generally, what happens is that you may want to have, for example, an Office 365, your user base, but what about if you want to add them to Azure? Well, do you need to go in and create a separate account in Azure, or can you have the identities with Office 365 propagate over to Azure? And same thing with Google, for example. Can you do that with Google? We'll talk about how G Suite can work as well. Now, Amazon doesn't really have a good solution around that when it comes to software as a service. I'll talk about like AD, and the reality is that, well, it's at least some areas to be desired with AWS, to be honest, with a lot of customer base that I have. But you can definitely make things federate with open authentication, like, for example. But again, if you're using like G Suite or you're using Office 365, that's going to be the bulk of your productivity suites that are out there. And generally, a lot of organizations like to federate their identities. They don't want to have an employee with 7 different user accounts and all that. At least the corporations and enterprises that I work with that are at least a little bit advanced in technology, they try to avoid that. Now, there's plenty of companies that still don't federate, and it is a moving target, right? All right. You need to have what's called an authoritative source. In other words, you need to have a key management. You need to have what's called an IMR. Basically, that's an authority source. In the world of Google, you have basically G Suite that could act as that, or Cloud Identity, for example. And same thing with Azure. You have your IAM capabilities built in, and AWS sort of handles it somewhat similar as well. We'll go ahead and focus on that a little bit as well. Now, let's just clarify some other technologies you're going to run into around the cloud. SAML. SAML is going to be I would say, a fairly common approach to use in federation. This is more of an XML format. It uses what's called SOAP as well for its framework. And again, this is something common that you may see out there. OpenID is an open standard. This is typically, again, used quite a bit in a lot of cases. This is where you have like a relying party. For example, a lot of folks like to use Facebook or LinkedIn or, I don't know, whatever applications that are out there that you could use. Again, me being a little bit older, I don't really get into a lot of the social media stuff, but I guess you could use like, Snapchat, or I don't know, whatever ones are out there. Some of you may know those very well. I don't know. But basically, you could use, for example, like LinkedIn, or you could use Facebook, and have them act as a relying party to basically log into, for example, the Washington Post, or to log into sfgate.com, the San Francisco newspaper, or the Murky News out in California, whatever. But also, too, you could also use it to log into Amazon now. Again, it's up to you on how you want to federate. Now, generally, you don't want to use OpenID in an environment like an enterprise. The last thing you want to do is, let an employee log in with their Facebook account to corporate enterprise services, right? That doesn't make any sense whatsoever. This is good for consumer-facing services. Now, a couple of things to talk about would be when it comes to identity services and the participants, you're going to typically have an identity provider, a relaying party, and then yourself. So, for example, you could choose, like in Google Cloud, Google can act as the identity provider and also the relaying party. And then it's yourself. Or you could go out to a third-party service, such as TELUS or RSA or any of the other services out there that you may want to consider for logging in for your identity management. Plenty of those services that are out there. Now, federated identity can certainly enable some benefits, but it can also enable some risks. Everything from crossing security domains could be a challenge. It could also, again, we talked about some of these attacks like man in the middle, session hijacking, etc. These type of attacks could be made easier with federation in some cases. In other words, whoever catches, the certificates or the identity credentials, if you're federated, then what happens? Well, they can gain access to a wider variety of services throughout your enterprise. Again, that could be a pro and a con depending on how you look at it. Interoperability can be a challenge as well. Now, multi-factor authentication, probably the most widely used example, and the one I'm just going to use just like every other training course uses as well, and vendor uses, is the ATM example. So, for example, most people probably have an ATM card, and that ATM card is something that you have. However, you also, for you to use that ATM card, you need to have something in your head, right, called a PIN. That PIN number could be usually 4 to 6 or 8 digits, depending on the bank and whatever is supported. But generally, it's at least 4 digits. And the PIN, you need to know in your head. You don't want to write it down and lose it, because if you do, then what happens? Someone can copy your card and, lo and behold, they have the keys to your kingdom, at least, to your bank account in this case. So a knowledge factor is something that the user knows. A possession is what you have, which is the card. And an inherence factor is something that only the user is. So again, those are ways to compare multi-factor authentication. Now, most cloud providers use what's called the least privilege access. Well, this is where you want to grant permissions with the least access so that it makes sense. For example, you don't typically want to give cloud auditors, basically write or deployment privileges. You just need to give them read permissions or view permissions, depending on the platform. The last thing you want to do is give more access than what you need. Again, most people are good. However, what happens, if someone has a bad day, they type the wrong command, or they get, or probably one of the stupidest things that you could do is sit in a Starbucks location in Manhattan let's say, and access your enterprise resources from there. Well, a lot of people don't know that. And, again, everyone on the call is pretty technical. But what happens if one of your, I don't know, liberal arts major managers who doesn't understand that he went to the wrong Starbucks Wi-Fi access port and he actually hit a spoofed wireless access point? That happens more often than not in a lot of these locations. And once that's done, that's like a man-in-the-middle attack. Everything's being collected. So quick story before I move on. I was over at VMware back in 2000. It's actually a VMworld, which is like one of the large conventions for virtualization folks with VMware. This was back in 2015, I think. What is it, 2000? Yeah, about 2015. And I had a partner that I was working with at the company, and he was out there too. And we were going between the different, what I would call buildings of the Moscone Center. Anyone that's been to San Francisco and has been to Moscone Center, you know that that is not just one building. It's actually a collection of different parts of the city block that it's on. So you have the east and the west and, the north and the south or whatever it's named. Well, anyways, I'm over there taking, classes, and I'm one of those folks that I never use a public Wi-Fi. I bring my Verizon, my, wireless router with me, and I just avoid all the hassles that you run into with the Wi-Fi and reduce just the risk 100% pretty much. However, he decided he didn't have a router, so he decided to go use a Wi-Fi. Well, he's one of those folks that is pretty sharp on what he does. He notices everything. So he was looking at, the properties and figured out that one of the MAC addresses essentially was different from the other two he had looked at. So when you go to these events, you go to different buildings. Chances are, if you go to VMworld or Salesforce or Oracle World or whatever, these events are going to be throughout that whole center. And you have to go to different buildings for different, training events or seminars or whatever. So he's going between each. And essentially, he noticed that two of the properties represented Cisco equipment, and then another one represented Hawaii. Again, sort of odd. So he says, well, this doesn't make any sense. So he then says, something isn't right here. So he downloads this tool, I forgot what it was called, to check the latency between his private lab at home and San Francisco where he's at. And he noticed that the Hawaii router was adding another 15 to 10 milliseconds or whatever. And I said, well, that doesn't make sense. So he gets the VMware management team and gets a hold of the right technical people. But to make a long story short, what happened was that when these conferences are planned, they typically have these conference planners basically outsource all these services, everything from setting up the booths to the Wi-Fi routers. So guess what? Everything was set up by a third-party contractor who, oddly enough, drew in a rogue wireless point into one of these buildings and was collecting information. So if you went to your bank account on this Wi-Fi, they got it and were able to save this information. With that said, this stuff happens quite a bit. Okay, role-based security. You need to look at role-based access. We all know what that is, right? You want to have administrators. We want to have viewers. In the cloud, for example, you're going to have application viewers, deployment managers, depending on, your cloud provider, and the reality is most of the cloud services you get as granular as you like. Separation of duty, that could be used as well. So for example, you don't want to give one administrator full admin rights to all your cloud services. Try to segment that. You don't want to be like the Texas Boot Company in El Paso. I'll talk about that case study here shortly. And data security. So this is a quote from Forrester Research. This is a little bit back in 2013, but it's still valid today. You need to design your applications, and security should be the focus. That really is the message. Geolocation. One of the things to pay attention to is that you're probably going to have a geography of users. And what I mean by that is, if you're a multinational company, anyone from and again, I'm just saying examples. I don't know who's on the call from where. I'm just, just throwing it out. Let's say you're from General Electric, or you're from Boeing, or you're from, Ralph's grocery store, or whatever the company is, or IKEA, whatever company. But if you have a worldwide workforce or worldwide user base, then you just can't control, who's accessing from where, because people work from different locations probably, and they probably also travel for work and for pleasure as well. However, you could certainly use geography to your advantage, and having a data center-centric approach could incorporate specific concerns. Now, one of the things where geolocation matters a lot as well is compliance. And compliance, unfortunately, has been lumped in with security. Now, this could be a good thing, or it could be a not so good thing, depending on who you are and the company that you work at. Compliance, in reality, is legal. It's not security. It's governance, not security. However, a lot of the controls you have to implement are going to be considered security controls. So we need to look at that and realize that compliance and security have been married, and they're not going to be separated anytime soon, okay? It is what it is. So compliance is like one of those areas where it's, it's administratively burdensome, and some people just don't appreciate that. Okay. All right, let's talk about the data security lifecycle. Now, one of the things to pay attention to is when you create something, a lot of companies are amazing at creating stuff, but they're not very good at destroying or archiving their data, having a life cycle, basically. So you, as the cloud engineer, the cloud administrator, the security analyst, or whatever your role is, you need to realize that every second of the day in most enterprises, data is being created at 2 to 5 times the rate it is being deleted. What does that mean? That also means that if you're a data storage company, that's good news for you, because data is being created much faster than it is being deleted. And therefore, customers are storing more and more data. Because of this phenomena, basically, which has been created for a couple different reasons, the one is going to be compliance. Another reason is because it's cheap in the cloud. It's not as expensive in a lot of cases. Companies look at the cloud as like an OpEx exercise and not a CapEx exercise. So if your bill goes up $200 for cloud storage tomorrow, then it's not a big deal. However, if you had to go out and purchase a new EMC or data storage array tomorrow, then that could be a big deal, right? Again. All right, let's see. I think we had a couple. Okay, Linda, did you have a question, Linda? Okay. Okay, Linda, can you feel free to talk, Linda, if you like?
No, I didn't have a question.
Oh, okay. I saw your hand up. Okay. Okay. Thanks. All right. And all right. Okay, that's about all the hands up. Just want to make sure. Good. Good. Okay. All right. So we know at least the audio works. Thanks for clarifying that, Linda, as well. So that was very useful, actually. So if anyone else has questions, the audio does appear to be working if the mute has been adjusted, I guess, on your end. Okay. Now I think we all understand that. I got 12:39, so I want to get to some demos here. Let me just see where I'm at. Okay. Another area, too, is around process integration. And what I mean by that is you have to look at how you're accessing your cloud application. And as part of that, you can have many different layers. And you may have to look at, am I accessing this directly with an API? Am I not? Am I using several APIs? What is the method that we're using? What type of encryption are we using? So on and so on. So you need to look at, can you use in transit or can you not? Now, some cloud providers do basically data at rest encryption and data in flight inside their cloud platform really well. However, data in transit or data in flight, as it's known as well, may not be addressed very well. And therefore, you need to look at different options. And again, we talked about data at rest. Like, for example, in Google, everything's encrypted inside the Google Cloud Platform, but also at rest. Now, if you want to encrypt from Google Cloud to your corporate data center, basically, well, you need to get the right solutions to be able to approach that. Because again, most providers don't have a good solution. Now, you could, of course, use third-party VPNs and all that, but we're talking really more encrypting like the data when you create it in the cloud and then save it somewhere else, or you create it locally and then you save it in the cloud, so vice versa. So again, encryption and decryption. Key management. This is another area that that I find typically a lot of organizations do really well, and some organizations don't do as well. Now, there's basically three approaches to this in the cloud. You can use what's called a legacy hardware security module. This is an HSM. So this would be like you going out to RSA and getting this security module and basically using this for your cloud services. And then you have a key management service. This is typically a third party, and it could be like RSA, it could be TELUS, but it could also be like, what is that, VeriSign, Network Solutions has a service as well, and you're just using their services for key management. And then some providers have what's called an HSM as a service as well that is available. And HSM as a service, actually, let me hold off on that. So HSM, a hardware security module, is exactly what it sounds like. It's a piece of hardware. The goal of the hardware is to store your keys, manage your keys, provide encryption. And now these of course, can support different approaches. Depends on what you're using. You want to make sure that they support the standards that you need. For example, common criteria is very common in the federal government. In the US, we have what's called the NIST FIPS. And also, too, a lot of corporations subscribe to that as well. And then when we use HSM in the cloud as well, you want to look at, for example, and, you know, again, different providers provide different capabilities. This is very similar to what AWS would provide, for example. but basically you could basically use this on your own, or you could use it, in an integrated approach is the way to look at it. You could also use part of the service or just partial of it. Again, it's up to you to think about how you want to manage this. In Google, we have basically cloud identity, for example, as well. Okay. All right. Any questions? Okay. And then monitoring. Okay, so let me hold off. I'm going to go to my browser now. And let me make sure I'm on what slide I'm at so that I have an idea when I get back. Okay. Now, let me share my screen and share my browser. Assuming I can find it. Where'd it go? There it is. Okay. All right, and y'all should be able to see my my browser. So I have AWS up for this turn. I'll look at Google as well, and then I'll bring up Azure as well. I'll try to do as much as I can for time purposes. I get 12:44. Wow, time flies when you're having fun. One of the things I want to talk about is security features. We're going to get to more specifics for each of the platforms shortly. Now, each of the providers, they look at this a little different. And what I mean is some of the features are sort of built in automatically, and some of the features are a little bit more adaptive where you have to build them in yourself or integrate them yourself. Now, in Google, for example, we have some security features, and I'm going to talk about DevOps and application development, because one of the things that I believe in is you want to design your application from the beginning to be secure and try not to deploy it before it's actually secure. Now, for those folks that worked as Windows administrators back in like 2000, 2005, you can appreciate how Windows was handled, right? What generally would happen is they would pump out these service packs, and these service packs would be great for overtime. And what I mean by that is this, right? That service pack could have 100-something, basically patches in it, or fixes, hot fixes, cold fixes, or just we'll throw it at you for the heck of it fix, as I call it. And, you'd always have a problem after you would, deploy that service pack. And you don't want to develop applications like that. Now, Microsoft has gotten significantly better, and I'm not, pounding them for that or anything, but one of the things you want to look at from a development perspective is try to figure out what is part of your cloud platform that can enable your developers. So, for example, in Google Cloud, we have App Engine. There's some really cool features that have been built in, such as we have what's called security scans and firewall rules and quotas. So, for example, security scans, if I select that, again, I have to actually create a scan, and I have to go through all this to set it up, and I don't think I even have an application running. But again, I'm not here to demo Google Cloud anyways, but I just want to point out a couple things to look at. So, for example, in Google, you have security scans, and you could use this not only in App Engine, but also, now App Engine's platform as a service, and then you could also use this in Compute Engine as well, and it's the same service, see if you see there. Now, one thing that you do want to do is, again, when you create a scan, and if you had an application running, you could scan against, and I do have something running. Oh, it's not actually deployed. Yeah, I have a Hello World application running. If you see the Hello World right there. And again, okay. All right. So anyways, you go over here to App Engine, again, security scans, firewall rules. One of the things that you'll want to do with your development team is make sure that they have at least one, if not two, types of development roles. And I'll talk about why when I get to the DevOps part of the course. So that's just one thing. Another thing, too, is if you go over here to security scans, you can see that they have Cloud Security Command Center. Now, Cloud Security Command Center is basically a new tool. It's in alpha mode or beta mode. Let me go check now. And this is actually going to be really cool. That's weird. Okay. Yeah. So, for example, this is not what I wanted. Hold on. But this is actually a tool I was going to point out. So this is actually a audit tool that you could use. This is called General Audit Tool. And basically, this is going to audit your environment for compliance purposes, such as HIPAA, CSA Star, and also the EU Data Protection Directive. So this is, again, security, something that you could use. You could try this for free as well. But this is an audit tool that could be used. Better yet, why don't I go to Google Cloud? Actually, this thing's in my way. Hold on. Sometimes it's easier just to go to the page and find it there because, okay. All right. Now, so Google, as you can see, if you go down here, and they always update their web. They're becoming like AWS now. It's to the point where I don't even recognize anything. And if you go here, this is all your G Suite. I'm going to talk about G Suite. It's got a lot of features that are comparable to what you could do with Office 365 with Azure. So G Suite and Google Cloud sort of, are on the same path. And let's see. What are they doing here? My gosh, this is driving me crazy. All right, let's go to products. All right, that's what I was looking for. Okay, so over here, there's actually some interesting security services such as Cloud Armor. Now, Cloud Armor is actually in alpha mode, and this will give you some protection against DDoS attacks. And the way this works is through global load balancing. One of the differentiators with Google versus like AWS is that the load balancing is a managed service, and there's no auto scaling, what's called a warm-up time that you have in AWS, which is actually cool. So you could spin this up a lot easier. Another solution that I would like to point out before I move to AWS and Azure is, and give me a second to find it because, again, they move this stuff around more than I like. Here it is. Identity and security. Now, Cloud Identity is going to allow you to manage your identities, devices, and applications from the console. And again, this is a managed service. This is essentially an ID as a service, identity as a service. And then under security, they have different solutions here. As you can see, you have Security Command Center. So this is one I was going to go to show you as well, beta. So this is in beta right now. And this is basically similar to CloudWatch with the twist of basically CloudTrail built in. this sort of allows you to get that insight using a monitoring solution with auditing and visibility sort of built in all at the same time. So it also works as well. Where was I going to put it here? Yeah, right here. And I'm going to talk about this. This actually is sort of cool. It has anomaly detection. Now, Google, what they do with this is they use their algorithms that they use for Google Search and Gmail and other services internally to look at your cloud platform behavior, what's being used, when it's being used, to help detect issues with, who's doing what. And what I mean by that is, what about if someone decides to spin up a, let's say, an Ethereum mining pool, right? You want to be alerted to that. Or another thing, for example, could be someone, from a domain, let's say in Chile, is downloading, 50% of the files in your enterprise on, cloud storage. Do you want to be notified of that? So it looks for anomalies. So pretty cool. Okay. Now, if we go to AWS, we have CloudWatch for monitoring, for example. And then if you go over here, there's CloudTrail and all these other facets that are under what's called security, identity, and compliance. One of the things, if we have time, I'd like to go through Inspector. Now, Inspector allows you to run against your AWS environment, basically similar to what you can do in Google Security Scanner, but this is your environment as a whole. Whereas, for example, Google Security Scanner, which actually used to be, and I get confused because it used to be called App Security Scanner, but they changed the name to Google Security Scanner because now it's available in Compute Engine as well. And it'll also be released, I understand, for Kubernetes as well. With that said, you could run an assessment and find vulnerabilities, essentially. And this works on a subscription approach as well. So you'll want to figure out what's supported, what isn't, what is free, and maybe what is not free. They have a wizard here. You just go through. You could run it weekly, run it once. There's an advanced setup, which is actually sort of cool. Go next, go next. I'm going to cancel that. But again, if you wanted to start it, you'd run it weekly. And when you choose that, it'll check for ports that are reachable outside your VPC. Now, what's a VPC? That's your virtual private cloud. It's going to check your hosts. Make sure that there's no vulnerabilities that are listed in the common vulnerability indexes. It's going to look for hardening issues and best practices as well. For example, you deploy Ubuntu Linux, and whoever installed Ubuntu Linux left your directories at 777 or something, right? You don't want that. That's just crazy, right? That means anyone can open and modify and adjust, right? You don't want that. And then you just go, okay, and then, and of course I had to leave that in the way. So this is going to run an assessment against the environment. Now, I don't have much going on, so it's not going to come out with too much, except for perhaps one VM, and it's running actually 3 instances. Did I spin up 3 instances? I did. Yeah, I did. Okay. But anyways, again, it'll run against it. It'll let me know any issues, but I don't have anything running on top of this, so it's not going to come up with a whole lot. Okay. So let's get back to the slide deck. We'll get into some other facets here shortly as well. And should should be where I want to be. All right, good. Let me move this out of the way. All right. And monitoring, right? When it comes to monitoring, you want to, make sure that you're able to monitor what's going on. For example, in Microsoft, you have the Azure Management Portal, you have App Dynamics, you also have capability in 365. Google App Engine and Cloud, you have GApp Status Board, Google Stack Driver as well. Now, Amazon, you have Cloud Monitoring, Cloud Watch, and you could also monitor Amazon Web with Stack Driver as well. Stack Driver is a hybrid solution that was actually a solution bought by Google. Before they got bought by Google, they were managing AWS as well. They got bought by Google, and that's how that came to be, which is actually a good feature because it sort of enables Google Cloud now to have a good argument over maybe why customers can, use Google Cloud and AWS and see what's going on at the same time with an integrated platform. So, continuous monitoring, you'll want to look at ways to implement continuous monitoring, identify risks, create your strategy, but also to implement any fixes. Operationalize means that you're going to go out and address this. Continuous monitoring, again, is, sort of like running what I just ran in Amazon, right? Trusted Advisor, letting that run every, set period, whatever that set period is, to identify issues that might come up. For example, let's say a developer, makes redundant copies of snapshots, and those snapshots are deployed as on a test bed. Well, it could be that the developer makes fixes on, the production-ready development instances, but doesn't make them on the QA or the other deployments, whatever they're used for, right? Or maybe they do A/B testing. These are things that you'll run into. And if you perform continuous monitoring on your whole cloud environment, like in Google, all your projects, or in AWS, your organizations, then, at least that way you could identify what is really going on. Excuse me. Now, when it comes to security operations, one of the things that you want to typically do is have some kind of security operations center, have folks monitoring stuff, goes without saying. You really should have a SOC center, that is going to identify vulnerabilities, threats, be proactive, not just reactive. Security operations is also a shared responsibility in the cloud as well. So AWS, Google, and Azure are going to be monitoring what's going on their environment. However, they're not going to typically be monitoring specific, instances or whatever on your managed part of the cloud. For example, if you deploy a VM, that's up to you to monitor that. However, they will get involved if for some reason they see that an attack is coming from your EC2 instances or your Azure VMs or Google Compute Engine VMs, and will mitigate the threat if they need to. So for example, if you're trying to go what I call cross-border, where you're in a project or you're in an organization or you're in an Azure directory or wherever you may be in your cloud service, you can't really just transfer between one organization to another. Now, when it comes to firewalls, again, some providers like Google and AWS are pretty straightforward. Azure as well, you have what's called, I think it's called, the web application firewall. You have DDoS protection, Azure firewall. And then you also create what's called security groups as well in AWS, Google, and Azure. So a lot of things that you could do to mitigate issues. Because what can happen too, I've seen this happen, especially in a larger multinational organization where compliance is very strictly regulated. For example, if you're let's say a financial institution, and you do business in Britain, and you do in England or whatever they call themselves nowadays over there, United Kingdom, right? You need to pay attention to a lot of compliance requirements. And then if you do business in the US, there's a lot of other things that you have to pay attention to. And Singapore is very heavily regulated as well. But with that said, what I'm trying to get at is, what about if you have someone in England try to copy stuff from England over to the US? Well, that could be a huge compliance violation depending on what type of data that is. And again, you need to be proactive with these areas. Another thing too you want to pay attention to is the ConOps. Each cloud provider has what's called a ConOps, a concept of operations. Sometimes they're not exactly called a ConOp. They're really more focused on what is called a statement of work, and here's what we're going to do. But again, concept of operations can go by several different terms. Basically, this is going to tell you what the provider is going to handle, how they're going to handle it, how they're going to manage the service. Now, in the federal government, ConOps is used quite a bit. FedRAMP is the federal government approach to cloud computing governance, essentially. There's a lot of terms there. I won't cover that per se, just because the audience seems to be pretty much widely dispersed and may not be a focus area, but I threw it in there just in case folks are interested in learning more. Now, generally when I teach cloud security, it's a 3-day class and I have time to cover all these. But one of the things I've noticed around FedRAMP is that there are a lot of commercial companies that are not even in the US, and they're actually following a lot of these what's called basically governance structures that FedRAMP uses. So this is sort of valid in some respects to everyone, because it depends on your industry and what the company's looking for a framework, but FedRAMP can actually fit in pretty well in some commercial sectors as well. Security operations. Now, you as a provider, you have responsibilities to handle your keys, manage your users, update your VMs, so on and so on. When it comes to system hardening, using solutions such as Trusted Advisor or whatever you're going to use, you could use other solutions that are third-party as well. That can help. But with that said, it's up to you to determine what you have to manage. Now, what you have to manage and harden is going to, of course, depend on what? The service model and the deployment model. Okay, now pen testing. One of the things that you should do is try to run pen tests against your cloud environment. However, every cloud provider has rules of engagement. Google Cloud says, don't bother us. However, you will bother us if we see that you go outside of your organization or projects. what that means is that you're allowed to pen test against your own CEDR network, against your own network in Google Cloud. However, once you try to traverse outside of that network, you then get outside of the rules of engagement. I had a customer about 4 years ago. This was before Google Cloud was really Google Cloud. They were just, playing around with App Engine and some other services and didn't realize that they went over their CEDR range and their service was literally shut down. Also, too, another thing that can happen is if you try to run a DDoS attack from your own subnet, which is, stupid, you need to realize that that violates a lot of the rules of engagement. And that's like a red flag to all the cloud providers. So you need to look at a lot of things. This is like literally a one-day class to talk about pen testing. Okay, DevOps. What I like to do is take a 5-minute break, and then we'll go ahead and wrap up the remaining content and get to questions. I've got 1:09. Let's come back at 1:14 p.m. Eastern Time. Okay, welcome back from everyone from break, that is. We've got 1:14. Let's get started. We have a lot to cover. I'd like to get some questions before we break as well. DevOps. Now, DevOps is one of those words that you're either going to want to deal with or maybe not want to deal with. It really depends on your organization, but it's important to know what DevOps is because a lot of organizations are becoming more proactive in developing their applications, which in turn are deployed to the cloud. So as a cloud architect or cloud engineer, or even a cloud developer, these are going to be some areas you're going to want to know down the road. So continuous integration, continuous delivery, continuous deployment, these are all terms that you may want to know. I put the sort of the brief description in there for you. If you go to puppet.com, they have a great comparison as well. Here's an example of a DevOps pipeline in Google Cloud. This is where you're going to use specific services in Google or AWS or Azure to be able to deploy your applications from basically development to test to production, etc. Here's a comparison of DevOps between Google Cloud and AWS. These are some of the services between like cloud repositories and code pipeline, cloud build, code deploy, so on and so on. But there's a couple best practices when it comes to DevOps that you really want to know if you're ever in an environment with DevOps deploying to the cloud. There's a lot more than this. These are just sort of the main ones that I typically run into. The first is an organization deploying apps to the cloud should look at DevOps as a cultural issue. In other words, those silos should be broken down between development and operations. You should be able to take advantage of native services that are part of the cloud platforms that you're using. You want to create custom images, so you want to use, for example, tools that are part of your infrastructure that you're using, whether it's Google, AWS, or Azure. So for example, Deployment Manager in Google, CloudFormation in AWS, etc. And let me just touch on a few of these. Okay, the last thing really, for time purposes, I got to speed up a little bit, but you want to keep it simple, right? Try not to make things more complex than you need to. For example, here's an example in Azure. So with Azure DevOps, this is a cloud-hosted application that you could use for your development projects. And it's based on what's called Team Foundation Server. Azure DevOps can manage your code and create a pipeline, essentially, a build. And again, it's using containers to help facilitate that. Let's talk about AWS. So this is where we're going to get into specific platforms and talk more about the security model, best practices, features. Again, I can't cover every little thing in every little platform, but I'm just highlighting the main ones that seem to come up more and more. AWS. So the AWS security model is really reliant on using EC2, and you're going to typically use 256-bit AES encryption keys. The firewalls are built into Amazon VPC. Now, a VPC is a virtual private cloud. It's like a sandbox. It does have a web app firewall as well. AWS has IAM, of course, and also multi-factor authentication and directory services. This is to enforce policies. AWS has an audit-friendly service for compliance requirements. By far, AWS is probably the most advanced in this area. And what I say by advanced is their history and their implementation of compliance standards, but also tools for the customers is well above Azure and Google from what I have seen. In AWS, when it comes to policies, you typically create a policy and then you would grant specific access down to a specific topic, for example. And then you could also allow full access as well. But one of the challenges is you don't want to, give everybody administrator access, right? That's not something you want to do. You want to create a custom policy and add them typically to a resource group. In AWS, there's also an abstraction layer between policies and accounts as well. Generally, companies find it easier to group policies into roles and then assign roles to groups and users as required. Now, they find it easier. That doesn't mean it's more secure, but they find it easier. It can work as long as you pay attention. Now, how does IAM get handled in AWS? Well, with AWS, that directory service is integrated with their global identity services. So here's how it works. This is sort of interesting because it's done differently than Google and Azure. Basically, you have a root account. And this is what's called a top-level account for your organization. And you need to pay special attention. Now, a lot of AWS partners and vendors, they recommend that you don't use the root account, that you effectively delete it. That's the whole process in itself. You have to, put in the right billing and contact information. It's a little bit more than just a one-step process, but that's the recommendation, because if you give root access, or if you even have the account open, that exposes your whole AWS environment to a hacker. You don't want to do that, of course, right? Identity federation. This is a big deal as well. One of the unique things about AWS IAM is that you want to create accounts through the organization, not through federation. And the problem is, again, this is not a problem if you understand how it affects everything else, but you want to pay attention to how accounts are divvied up by the organization. And if you create an account in that organization, it's only used by that organization. If you use it through federation, then your access is a little different. Let's see here. Another unique element as well. Let me get some water. My throat's acting up here. Okay. Another unique element is that you can create your access keys and have what's called a non-interactive account. So this is sort of like a service account in Google Cloud, for example. And then lastly, too, this does differ with Google and Microsoft, where typically in Google and Microsoft, every organization is self-contained. However, users can end up, in most cases, with multiple sets of credentials to access different organizations. Once again, IAM is sort of structured a little differently. You have to know how it's structured differently, especially like if you're going to have, and this is very true, a lot of customers are running AWS and Google, or AWS and Azure. So the approach is a little different. you as the cloud guru need to appreciate that, of course. Some of the best practices, and again, this is not an exclusive list. You want to disable root login over SSH, and to do that is fairly simple, but you want to pay attention to what you're doing. Support the proper version of SSH. Disable password authentication. And again, a lot of this is common sense. A lot of this is what you're already doing in your environments. Password complexity. You know, enable the right encryption and authentication processes, right? Configure permissions for your directories as well. Try not to, you know, create your directories and buckets with global permissions. When it comes to some data services, again, I just put in a few areas that just come up pretty routinely. Ensure that no S3 buckets are publicly read and write open, right? For example, a couple years ago, 2 years ago, one of the largest defense contractors put NSA government classified information into a publicly open bucket. Again, those folks that did that shouldn't have a security clearance anymore, but I don't know what happened, but that's another story. It's ridiculous. And because here's why it's ridiculous, is because it takes effort to open that bucket to the public. You have to acknowledge a few steps. Now, if I have time, I'll go through those slides as well. Or I'll walk you through a demo, but I don't really have time, unfortunately. Encrypt data in EBS as an added layer of security. Now, one of the things with AWS, for example, versus Google, is not all the services decrypt, or actually I should say encrypt data at rest. EBS and RDS are two services that don't do that by default. You have to enable it. In Google Cloud, everything is by default, and you actually can't get around that. So again, Google and AWS and Azure look at things a little differently. A couple other things about RDS, for example. If you want to mitigate, for example, SQL injections, DOS attacks, again, restrict access. It's sort of like an S3 bucket. Don't open it to the world. These things take effort to do, but you'll be surprised how lazy people can be. CloudTrail, AWS, again, if you want to do auditing, CloudTrail is one of the services you'll probably want to do. For example, what happens if someone changes an S3 bucket from a private to a public? Do you want to be notified? Yeah, I hope so. Okay, let's talk about Azure. Let me get some water here. Now, Azure approaches things a little differently, but a lot of things are similar. So Azure as well, they operate data centers, they're geographically dispersed, and they comply with the major standards as you would expect, such as ISO, NIST, FedRAMP, FISMA, so on and so on. Azure uses Active Directory, right? Pretty intense there. If you use Azure, you have to know AD. And with that said, the way organizations are typically applied uses Active Directory as part of that structure. And domains, and you're familiar with those terms, for example. Azure does support various encryption models, for example. One of the things in Azure that you'll probably want to use is going to be the key vault. However, you could certainly use your own keys as a customer managed solution as well. For example, if you want to use, for example, Azure Security Center. Now, Azure Security Center is similar to, AWS Inspector, where it's going to go out and look for these best practices and notify you of what exactly is going on. It's a security management tool and a threat protection tool as well, sort of all in one. Now in Azure, identities are similar to Google's in the sense that Azure uses Office 365, and you could essentially federate or integrate those services. In Google, again, Google uses what? G Suite essentially as well. And then in Google, you know, will be a comparable, will be what? G Suite and Gmail, right? So again, similar approach. Now, Amazon doesn't really have anything similar to Office 365 or you know, G Suite. Now again, if you're using G Suite or 365, it could be a big convenience to use a federation approach with those services because of the fact that you can impose a life cycle and impose groups and strict policies and have it be federated, right? And again, at Azure's core, Active Directory is where it's at. Now, accounts, for example, that are used by applications and non-interactive services basically could reside inside Azure, and these are called service principals. Now, in Google, for example, it's called a service account, again. GCP Azure uses user accounts to switch between directories, for example. Lastly, you could have subscriptions and not have to manage a set of credentials as well. And also too, and I think I'm going to get to that. Did I? Yeah, I put that in there. Also too, some of your capabilities can certainly be dependent on an enterprise agreement. I'll talk about that as well. But Azure's IAM as well is a unique model in the sense that it's sort of between GCP and AWS in terms of flexibility. Now, again, that's sort of my opinion. You could, you know, address that however you want, but I'll leave that up to you to decide that. A lot of roles that are available. So Azure IAM makes it really easy to determine, you know, what role someone should have. Are they going to be a contributor, an owner, right? Those are typically the most commonly assigned. Contributor basically allows anyone to do anything to the resource within that scope. An owner is going to add, again, permission capabilities. And then you have resource groups as well. I won't, you know, read everything to you, but just some things to think about. Benefits of this could be, again, isolation, where you have these resource groups and you could track these deployments and make it simple. And then lastly, enterprise agreements. So if you have an EA with Microsoft, generally they recommend that you have a subscription typically given to a group in the company to provide that isolation from like chargebacks and permissions as well. And again, you could set up your EA agreement however it makes sense to you, but the best practice that Microsoft has is to create what's, you know, what essentially is a group. And then let's talk about Google. Now, Google approaches things a little bit differently, stricter in some respects than either AWS and Azure. Google, they basically store data on persistent disks by default, and it is all encrypted. Okay, so basically, anything stored in Google Cloud is encrypted by default, and it's really not optional for a lot of services anyways. So therefore, someone getting into your Amazon S3, okay, is different than someone getting into your Google Cloud storage. Is it encrypted or is it not? Did you encrypt it or did you not? In other words, that decision's already been made for you by Google. Okay. Commitment to enterprise certification as well. Now, Google is probably, out of the three providers, a little bit behind the 8 ball, I guess is how you would refer to that if you play pool. What I mean by that is they they're number 3 in the market, and they have like a 8-year lag time between like AWS and about 5 years between Azure. But with that said, they're building up their capabilities. Now with cloud identity and access management, this is again pretty similar in the sense that you could have roles like in Microsoft, but these roles are basically, I like to call this a layer cake approach. And the reality is in Google Cloud, you have the ability to get down to literally everything from location down to the service and what part of that service. So it's pretty granular. How granular are actually, what is the term? How detailed you want to get. It's really your call. Excuse me one sec. Let me just clear my throat. Okay, sorry about that. Now, again, like I say, between the providers, it's really, pick your poison. What do you need? What is the right choice for what you're doing? Lastly, when it comes to security policies, Google has a pretty robust ecosystem. Matter of fact, it's probably just as good as Azure, if not better, depending on the way you look at it. Now, Google, again, you have G Suite, Cloud Identity. Now, Cloud Identity is an identity service. It's basically an ID as a service, as it would be called. So if you're not using G Suite, you could use Cloud Identity to create your policies and manage your IAM as well. So a lot of capabilities there with Google. GCP uses what's called a project, a little bit different than Azure and AWS. Each project has its own billing structure and IAM config. A lot of granularity that you get immediately out of the gate. Organizations are basically what's called a project in some cases, or there's also a top tier called an organizational unit. So if you're using like G Suite or you're using Google at Work, let's say you have a domain hosted in Google at Work called mycompany.com, and you have 100 users as part of that. Those 100 users could federate with Google with Cloud Identity or G Suite, however it makes sense. All right, now I added some bonus content for Google Cloud as well. I'm going to skip through some of that because I want to make sure I have time, but it was bonus. I didn't plan on getting on it, but there is actually some interesting what I would call built-in capabilities of Google Cloud versus AWS and Azure, because Google uses their own infrastructure and they own everything, and they have the lowest latency network than any other provider in general. And they use a lot of these services internally, and what they did is they built their own custom solutions. They use it internally and then deploy it out to Google Cloud and G Suite. Google's view of the world is different. I'm going to go ahead and skip over that. Let me get over to where I would like to get. Hold on one sec. Okay, now let's talk about some additional things that are coming up lately in the world of IT security. Cryptocurrencies or blockchain technology. One of the challenges around cryptocurrency is that it can make people money that don't pay for the resource usage. I hope that made sense. What I am saying is there's been more than enough stories of folks that have used cloud services or in-house services to mine cryptocurrencies. Now, Last year at this time, Bitcoin, Ethereum, Monero, their market cap was like 7 times what it is now. So it's not as profitable to do right now. However, it's still profitable if you're not paying for the resources. What I'm getting at is it wouldn't be the first time that an employee would use Google Cloud or AWS. I haven't seen any instances on Azure, but that doesn't mean it couldn't happen, because you can deploy cryptocurrencies on Azure as well. For example, actually, what a Azure security scanner actually will scan for that actually as well. So it looks for that blockchain activity, which is actually sort of cool. But anyways, but it seems like AWS and Google are very popular for cryptocurrency miners. So you want to pay attention to that. So I don't see that when I put in slightly mitigated due to the market crash, a lot of people aren't taking the risk because of the fact that they know if they got caught, they could get fired, sued, put in jail. Again, unless if you work for the Federal Reserve, and yes, some goofball at the Federal Reserve was literally mining Ethereum and I think Monero for 2 years before he got noticed. Do you know that they never figured out in other words, money's no object to the Federal Reserve because they just print it, it's not even theirs. They just make the American citizens pay for that and pay more taxes. That's another story. I won't get into the political area of it, but in reality, they didn't notice. So it shows that the Federal Reserve has a very weak security posture because apparently no one's looking at their bills. But the way he got caught was this. He went in, he actually logged in from home and modified some permissions on access to one of the ports. And that set off a red flag to the Security Operations Center. If he had done this on site or did this from an address that was authorized for remote changes, he didn't pay attention, he wouldn't have got caught probably. But anyway, so he got fired, didn't go to jail. And what was funny is they still couldn't figure out how much he made, but the estimate was at the time he probably made about $700,000 to $900,000. Yeah, believe that. Okay, so this is a big deal. So what would happen if someone spun up Ethereum nodes in your AWS service? What would happen if someone spun up Monero in Google Cloud for you? Or what would happen if they spun up Ethereum in Azure? That supports that as well. Again, there's a difference between running an enterprise use case of this versus a, cryptocurrency scheme. So pay attention to that. Now, Bitcoin and Litecoin, you're not going to run into because they require ASICs. And generally, they're not even supported on most of these platforms. There are certain ASICs that could work, but Bitcoin and Litecoin, at this point, it just wouldn't even be worth the effort to set it up because you need really high-level, high-throughput ASICs to be able to perform BTC or LTC. However, Monero, Ethereum, Dash, these are currencies that the game is on. Okay. Here's some examples if you want to look at. There's a school principal that was fired for mining as well. Federal Reserve, the Russian scientists, my favorite story. Now, they were mining Bitcoin because they had ASICs on their nuclear testing computers or whatever. And then here's an example of some hackers that broke into AWS and literally spun up Bitcoin nodes at the time. This is about a year ago. And again, this could happen. And they also spun up Monero as well. So, okay, so what would happen if you had a rogue employee? You got to plan for these things. So it's so simple to spin up an AMI with Ubuntu on it and download MinerGate, for example. So you join a Monero pool, for example, and you launch. You could do this in less than an hour and start collecting money in less than a day in some cases. Now, there's different approaches to mining. Again, in the cloud, it's going to be typically, virtual hosted, but there's also hosted mining like Genesis mining. But in this case, you're worried about what's going on in your enterprise environments. Now, what are some threats out there? Some threats out there, just some. There's a whole list of them, right? What are they? A lot of these could come down when we talk about the cloud is the compromise of the platform itself. In other words, like with that AWS hack with cryptocurrencies, what had happened was, by default in AWS, I had mentioned this with like S3 and also some of the other services with EC2, it uses a global namespace. And if you're not paying attention to what you're doing, those APIs are hijacked and, you get Bitcoin mining or Monero mining happening without you knowing it. Compromise of credentials. This is where someone loses their credentials, they lose their PEM file. Developers are usually pretty good about keeping their keys, but sometimes they get sloppy, like they'll leave the PEM file on their desktop named .pem file for AWS. And they'll walk away from their laptops and they'll take a break in the break room. And it's possible that, things can happen. Anyways, you can figure that out. Or the developer's at home and he's on Comcast or AT&T and isn't using a VPN. Anyone, that has done any kind of security work knows that you could get basically a rogue access point and hook this up and collect this information with very little effort as well. And you could also use development tools as well against your own company. Denial of service, DDoS attacks, very common. Compliance implementations. Okay, training for people. In other words, if you don't train your people on how to do something, then you shouldn't expect them to do it right. And you will be surprised at how many companies don't do things right still. Here's an example of Gartner sort of giving out some sort of thought on this. Basically, 95% of cloud security failures will be the customer's fault. Yes, more than 9 times out of 10, if you have a security breach, it is your fault. Yes, it's not the Russians, it's not the Canadians, it is not that student sitting up at Berkeley, it is your own people, and that's the truth. I can tell you right now that in the last few instances that I've been involved with in the last 2 years, every time someone is not using the tools that were given to them in the first place to run vulnerability assessments, or they didn't manage, or one of the common areas is mobile. Mobile is mobile. It's a wide open marketplace for those that like to feast on vulnerabilities. Okay, so how do we mitigate these issues? It really depends. One of my favorite quotes is this from Mr. Gandhi, essentially, the future depends on what you do today, right? Everything depends on what we do today, okay? Whether you like it or not, you accept responsibility or not, that's up to you. But again, you could have money saved or you don't have money saved. You could have a job or you don't have a job, okay? Okay, you could be married or you're not married. You could have kids or you don't. Again, and you could take this into IT security. You could have your vulnerabilities remediated or you don't. You could have your holes, your ports closed, that shouldn't be open. It's up to you. So it all comes down to your behavior today. You get to learn something new today. In other words, if you got a free invitation to an Azure webcast on cloud security for Azure, and you manage Azure, then if you don't attend it or listen to the recording later, and that vulnerability comes up, it's your fault for that vulnerability happening. Just like with Equifax, one of my favorite examples. Okay, so as you can see, I'm not a big believer in excuses. I come from a military background, okay? Saying it's someone else's fault is not an excuse, okay? Here's a good example of what you should not do. This is where training comes in. This is where you hire the cheapest people for the cheapest rate comes into play, okay? And I hate to say it, I knew actually one of the persons involved, he pretended his role from day one. And if you ever know about government contracting in the US, and again, I did the work, I was in the military, I worked for contractors, I've been on over 100, well, probably about 80 military bases. And I can tell you one thing, most of the people in government contracting are not type A, they're type B. They react instead of be proactive. So this is not a surprise. This happened at least 4 or 5 other times, and it will continue to happen because, again, these people are lazy and uneducated. Again, it's up to you to go back to your organizations and take responsibility for your cloud infrastructure. Okay, if you don't have training, and to be honest, there's so much free training out there, even if you can't afford to take training, there's so much free that it's next to impossible to still not have a clue. Or most companies pay for support, so get the training you need. That's my sort of thought on it. And if you take more classes, great. It's up to you. Okay, so what these folks did is instead of adding the keys to their APIs and applications, what did they do? They open up the bucket, okay? And I'm going to be honest, it takes effort to expose an S3 bucket. Okay, you not only get one flashy light, but you get 3 flashy lights, okay? It's sort of like you driving down the road with a light, okay? You know that if you get a green light, you're good to go. But you get that yellow light, which is right, the first slide, saying you might want to think about it. But in this case, they got a second yellow light saying slow down. Instead of like a yellow light, it's a flashy yellow light. And then they get a red light saying it's totally open. And I didn't put every interface copy in there just to give you an idea, but it takes effort. This should not have happened in the first place. Because Amazon S3 is about the easiest cloud service for a hacker to get into. It's hideously easy. And yes, there's tools out there that you could run for free and download on the semi-dark web to figure things out. I'll leave it at that. Okay, now here's a quote from Tripwire. Did you know that in 2017, over 99 billion records were exposed because of data breaches? Pretty amazing, right? 99 billion is a lot of data. Cloud computing, there are a lot of considerations that you have to look at with your APIs, for example. AI is another big deal. You could use AI to your advantage, just like what Azure is doing in Security Center and what Google's using as well. Or you could use it or have it used against you. In other words, people are using AI, especially like what I call the script kiddies that are really good at programming. They can figure this out really easy. So AI is what? AI is basically behavioral learning in the sense that it's sort of reacting and sort of building on that reaction. So it figures out that port A is open, but what about if port B is open and port B and C is open? What does that mean? Well, maybe it means that every port's open. Or, could be any number of things. Or are they using, for example, specific applications? Now, again, it really depends. Now, also, these type of vulnerabilities and attacks are basically called entity behavior analytics. That's a term that you're reading about quite a bit. Another one from, I think this is from Forrester. Did I not put that in there? Oh, it's the Insider Threat Report. Basically, 50% of the companies plus, it cost them over $100,000 to fix what has happened. 12% over $1 million. So what are the top 10 things you could do right now to reduce your risk in your enterprise? Okay, improve your key management. Enable audit logging. Believe it or not, a lot of companies do not still audit everything that they do. Now, auditing costs money. It is storage, don't get me wrong, and it can be bandwidth depending on where you're logging to, but it needs to be done. If you don't audit, you're literally a wide open pig. Okay, it's sort of like listening to, the U.S. government saying that they don't know who leaked that stuff to WikiLeaks. Okay, they know who it is, and they're totally embarrassed by it. They'll just leave it at that. Again, I just love talking about these things because these things that happen or they shouldn't happen, but they do. Or they know what has happened. For example, companies know what has happened, but they don't go public with it. Again, a lot of it is just bad culture, I think, in some cases in companies and governments for that matter. Okay, lock down the protocol. If you don't need to have RDP open, don't leave it open. If you don't need to have HTTP open, but you're going to use HTTPS, don't leave it open, right? If you don't have employees in China or in Asia, and you're only based in the US, then don't let people from domains of .China or Vietnam or something access the resources by default. Sure, you may have salespeople traveling or employees on vacation that might need to access resources, but there's things you could do to lower access, right? Use least privilege. Goes without saying, right? If someone only needs view access, don't give them write access, right? Review your DB services. Now, we know SQL has a lot of vulnerabilities, and then the applications that are right on top of SQL can have a lot of vulnerabilities. SQL injection attacks, CSS issues, you name it. Multi-factor authentication. Okay, there's absolutely no excuse why your employees are accessing from their house AWS, Google, or Azure without multi-factor authentication, other than the fact you're being lazy as an organization. That's usually what it comes down to. Encrypt. Okay, I don't have to really expand on that. We know what encryption is. Lo and behold, each provider has best practices. Look at them, read them. AWS has the best documentation in the business. In my opinion, if you don't spend a couple weekends or weeks reading it, it's your fault, okay? AWS has tens of thousands or hundreds of thousands of pages of documentation. They tell you everything. Azure does pretty well, and Google is just figuring out documentation. You got to give them a little time, but you know, it's getting there. So build security into DevOps, right? DevOps is coming. Lastly, APIs. Have endpoints. Okay, it's one of those things. You don't let your developers just log in, you know, without authorization. Contrary to what you would think, this happens more often than not, and this is where most of the vulnerabilities get exposed. Have a proxy. Enforce endpoints on your development team. Okay, how do we also address issues in the cloud, get training. Again, you know, I'm not here just to sell you training. I'm here to give you advice. Get training from the vendors if you have to. Get it from WebAge. Take free WebExes if they're available. If you have time, watch YouTube. On the other hand, you know, definitely take a class if that's in the budget as well. There's plenty of training out there. Some certifications you could also, you know, look at as well. Could be the CCSK, CCSS, the CCNP, that's Cisco, ISC. There's Professional Cloud Security Manager by Cloud Credential. And then AWS has a really good security specialty as well that I can't even pass as of yet. They've got this special formula. It's a very hard exam. And again, if you could pass that, kudos off to you. On the other hand, Azure, I believe, is coming out with a specialty, and Google, I'm not sure what the plan is as of yet. Okay. Now, a lot of upcoming classes on WebAge. Take a look at the Microsoft Azure Integration and Security course, AWS Solutions Architect. There's also Fundamentals of Google Cloud as well, and there's also Cloud Security Manager as well, which is a good vendor-neutral certification. All right, let's go to questions. Let's open it up for some Q&A for those folks that are interested. All right, I hope this was helpful to everyone. If there's no other questions, we're officially done. What I did want to remind people of is that you will be able to get a copy of the recording and the PDF download. The link was provided by WebAge in the early part of the chat. Download that. It's available for you to reference. There's a lot of links in there as well, so definitely look at that. All right, if there's no other questions, let's go ahead and call it a Thursday afternoon. I'm going to hang out another minute or two if there are questions. All right, let's see. We have a chat question here. All right, thank you so much, Alan. I appreciate your time. The recording will be, you'll get an email link from my understanding within like 48 hours. And then you could always go to the WebAge page under webinars to download as well. So if you don't get the link within 2 days, reach out to your WebAge contact and remind them, but it'll also be online as well under the webinars. Yeah, so the link is in the first part of the chat as well, and I don't even know if I can get to it. Let me see. Yes, thank you. Alex just posted it. Great. Thank you for sharing that again. And with that said, that's about all that I had. Please look at the WebAge website and look for any training that might be of interest. Check out the past webinars, and also feel free to reach out to me on LinkedIn or YouTube. My acronym or my code name is the Cloud Tech Guy. Thank you, everyone. I hope you learned something new, and please join us again in the future.